Video, I'm going to talk about the least square regression method and linearization of the power model, which is followed by several phenomena in engineering, which is denoted by y is equal to ax_b. And if you see your standard equation for your linear regression, that will just be y is equal to a naught plus a1x. So this is your slope, this is your intercept, right? So if you look at this equation, this is this is definitely a square, this is definitely a power function that does nothing looks like this. But if you take log base 10 on both sides, this will look like log 10, or I should say log 10 y is equal to log 10 a plus b log 10 x. Now if you compare it with your original equation, your y is basically log 10 y, and your a naught is log 10 a, and your b or your a1 is b, and your x is log base 10 x. So as you know, with your least square method, when you're trying to find your a naught, which is going to be equal to y bar minus a1 x bar, these are means, and a1, which is your intercept, which is your slope, is going to be n sigma xi yi minus sigma xi y xi sigma yi divided by n sigma xi squareds minus sigma xi whole sum squared. So here you use your input to the model. Here your input to the model is your x and y, and their statistical manipulation. But in this scenario here, your input will be log 10y and log 10x, and you would use those as an input to find out your a1 as b and your a naught as log 10a, right? So when you compare to this, so when you make this comparison, when you have to rewrite this in the form y is equal to axb, what you're going to have to do is you have to take anti-log on both sides, anti-log on both sides, and say 10 to the power a naught is equal to a, and then you feed everything into y is equal to ax to the power b, and you will be able to predict the values. So how will your matrix looks like? You're going to have x, you're going to have y values, and then you have to find the log 10x, and then you have to find log 10y, and then you will have to find whatever terms needed here. For example, you're going to need the squares of the sum of the x's, so you're gonna have to find log 10x squared, and then you have to find out the log 10 of x multiplied by log 10 of y. And you can use the same equation to find the sum of log 10x here, sum of log 10y here, and sum of the log 10 xi squared, and then sum of the log 10x, and multiplied by log 10y, and then you plug everything back in, find out these two things, convert that back to a, and plug it in here. So what I'm going to do is I'm going to use this example, which basically is two-part example. So what I'm going to do is I'm going to just take one part of it, the left-hand side of it, and then I will create the model for you, and then model, we will use that to predict the half marathon values for the men, and you can use it in any way. So let's move to the map. Okay, so now if I talk about the data that I just showed you for the marathon and their timings, and if I just plug that in for myself here, that would look like for the men. So let's call this XM vector. So XM is going to be equal to, for 100 meter, 200 meter, 400 meter, 800 meter, 1000 meter, 1500 meter, 2000 meter, 5000 meter, 10,000 meter, 20,000 meter, and full marathon, which is 42,195 kilometers. And then you will have your time for the men that it took for 100 meter. The world record is 9.58, 19.19, 43.18, 100.9, 131.96, 206, 284.79, 757.4, 1577.53, 3,386, and 73.77. That's that. So as I was saying, you're going to need the log 10 of the XM. So I would just say, I will just call that L10 XM is going to be equal to log 10 of XM, and then I'm going to say L10 TM is equal to log 10 TM, right? So as I said, for the, I ended up saying 20. Let me just change that to 10 so that there is no confusion. So what I'm going to do here is I'm going to use these two to get my linear fit, right? So I'm going to need my intercept and slope. So I'm just going to use polyfit for that. So I'm just going to say P is equal to polyfit of what? L10 XM and L10 TM, and I need first order polynomial. Now remember, MATLAB does it other way around. So you have this one as for your highest power, which is your slope, and this is your intercept. If you look at your intercept, to be able to make a model out of intercept, what you're going to have to do here is you have to convert it back to a by taking anti-log, which is going to be 10 to the power a. So I'm just going to say my slope is going to be a1, and slope is going to be a1, and my intercept my intercept is going to be equal to 10 to the power a 2, and that gives me that value. So to be able to make a model, I'm gonna need some x values. So I'm just going to say xp is equal to give me some x values as lin space between I would say between 100 to 50,000. Give me 100 values. So my yp is going to be my intercept multiplied by x to the power slope, and that will be xp instead, and that's my xp and my yp. If I plot these against my original xm and tm and give them the red dots and show them in comparison to xp and yp, how does that look like? That looks like this. So what I should do instead is I should show them on the log plot. So what I'm going to do is I'm just going to change this to log, but see my xp is really high. So let me just go and fix that one first. This one is this, and that also changes my yp, and that will change my plot to look a little bit better than this. So but still I want to see it on the log plot, so I'm just gonna say log of this, and that one represents the values of the man world record of different types of the races that we had. So now I have to predict for the half marathon. So half marathon is going to be, instead of xp, I just need max of xm divided by 2, not this. The whole max should be divided by 2. That will be half marathon, and this should give me the y value, and I want that y value to be seen here, which is 3,646. And if you look at the value of the real world record, which is going to be 3,500, which is pretty close. So that's how you use your power function or the power model to linearize and predict the values for the data that follows the power function. So I will make another video for the another linearization method, which involve the saturation population function as well.